For the autocorrelation function, we can know that first there should be a maximum number when v is 0. And also a Fourier transform should be non-negative, which is larger than 0. And also because there is no imaginary part inside it, so it is also should be even. And for the spectral density function, it should be non-negative. So let's see the first function. It is even, obviously, because there is an absolute part inside this function. And we can know that when v is negative or positive, they are all the same. And also for this function, it has a maximum value when v is 0. And I use a website to get the Fourier transform. That should be this part, this item. So it is larger than 0 because this part is positive, and so the result should be non-negative. And of course for this function, it is larger than 0, so it is positive, and it meets the requirement for the spectral density function. So it meets all the requirement. It can represent an autocorrelation function and also a spectral density function. And for the second function, we can know that it can write in this form. That is, it is a square of the part. So it is even, obviously. And I use the website to plot a figure. The function should look like that. So it is non-negative, and it also have a maximum value when v is 0. That is 1. And its Fourier transform is it is so it also meets all the requirement. For the last function, it is also obvious that it is even. And there are two parts inside this function. One is 1, and the second is 0. And the Fourier transform of 1 is and 0 is 0. So the Fourier transform of function is non-negative, and function itself is non-negative as well, and it is even, and it also have a maximum value when v is 0. So it also meet all the requirement, that is